This video was made by Sustainable Communities Initiatives, which is a Scottish charity working towards building zero waste, zero energy communities. SCI's strength is its creativity and its pioneering approach to living more sustainably. This video illustrates the building process of Earthship Fife, the UK's first fully functioning earthship with autonomous systems. Earthships were pioneered by an American architect called Michael Reynolds. He cites them as being independent vessels to sail on the seas of tomorrow. His intention was to build a house that would take care of its occupants in any climate without having an adverse effect on the environment. They're described as sustainable living spaces, self-sufficient in heating, power, water and sewage. There are more than 2,000 earthships in the world today. Many of these are in New Mexico, but there are also some in South America, Japan, Spain and Belgium. The main principles of an earthship are thermal mass and passive solar design. This reduces the building's dependency on fossil fuel for heating. Earthship Fife demonstrates these principles and, as you can also see, catches its own water supply, generates its own power demands and treats its own sewage waste. It is not connected to the main services whatsoever. Well, it was my trip to New Mexico in 2000 that introduced me to earthships. After a day's volunteering in the Greater World community, where I pounded my first ever tyre, I was bitten by a bug that told me this makes sense. In terms of sustainability and living lightly on the earth, it struck me as a good option to explore. I then wrote my master's dissertation on the viability of earthships in Scotland as a sustainable housing option. In theory anyway, at that stage, I answered questions such as, what would earthships look like in Scotland? Would they get planning permission? Would they work in the Scottish climate? What would they cost to build and to live in? And would people even want to live in them? The results of the research looked promising. The earthship looked more sustainable than the conventional houses in Scotland that I compared it to. It was time to build one and prove the theory. By the end of 2000, we found a suitable site for the UK's first earthship in Kinghorn, on the side of Kinghorn Loch, which is on the south coast of Fife. It's a great location, only 45 minutes from Edinburgh and an hour from the central belt of Stirling and Glasgow. The loch is home to Craignclough Farm and the Ecology Centre, which is a public site managed to cater for the local community and environmental education. The actual site of the earthship is approximately 12 degrees east of south, overlooking the loch and the herb gardens of the Ecology Centre. Building on this site, which is actually an agricultural site, means that residential status was not possible. However, we did settle for non-residential status for this first earthship with a view to finding out all we could about housing standards in relation to this kind of building. So in April 2001 we got full planning permission and received a 5-year temporary building warrant for the earthship. Michael Reynolds arrived with an earthship building crew in July 2001 to show us their skills and share their experience. And we had an eager group of people waiting from all around Scotland and England who wanted to build their own earthship someday. The engineer that we used for the building project was open-minded and curious about this new concept of a building made of car tyres. He visited the site every day during our 8-day building session to check the structural integrity of the building and later give us formal approval of the concept generally.
I don't think it'll hurt anything. What he was saying is putting an arc back here, and I don't have a problem doing that.
You mean a double course?
Not a double course,
just
an
a slight arching rather than there's been a straight line.
Because see, a lot of them are that way anyway.
Yeah.
We've done a lot of them that way, and I think that's a good point to do. Just
We chose to use ecological materials wherever we could when building the Earthship. This, however, was not an easy route. Factors such as suitability of the materials and the cost didn't make that easy. We were, however, very lucky to receive sponsorship from a number of companies that were keen to get involved in such an innovative project. The main difference between earthships and conventional buildings is the use of earth-ram tyres, which are really used as bricks. Tyres are a huge problem in Britain, with daily figures now around 140,000, and we have tyre mountains of up to about 40 million. Under the landfill directive, tyre disposal is no longer permitted in landfill sites. They don't biodegrade and they cause problems by destabilising the site. They also retain lots of heat, the very reasons they make ideal building bricks for an energy efficient house. Once tyres are filled with earth, they create lots of thermal mass. To fill a tyre, you use a sledgehammer and a shovel. The earth is shovelled into the tyre, in situ, in the wall, and compacted to 95%. It's a very simple pounding technique, which requires more stamina than skill, and approximately 2 wheelbarrows of earth are held in each tyre. The fact that they're plastered and buried means they're also fireproof. In addition to the mass of the tyre wall, which is about 2.5 foot thick, the Earthship is given additional mass by backfilling the wall with earth from the site and enveloping it in what is known as a thermal wrap. Basically, the aim is to create as much mass as possible as mass stores heat, until which time it is slowly released back into the building when the ambient temperature drops inside. Our thermal wrap was made with building materials called Voltex and foam glass, which were actually ecological alternatives to plastic and urethane. The purpose of the inner material, the foam glass, is insulation, and this is made from carbonised recycled glass, which is inert and doesn't biodegrade, which makes it ideal in a buried situation. And then on the outside of the foam glass, we have our waterproof membrane called Voltex, which is made from sodium bentonite granules and geotextiles. The adverse conditions during the building period meant we had to erect a tarpaulin to prevent the site being turned into a mudslide. Apart from protecting the building crew, we had some concerns as well about keeping the earth as dry as possible to speed up the drying process of the walls later. We used black sand to mix with the earth and the tyres. This helped to reduce saturation of the soil when it became too sticky to pound. Apart from using car tyres, which are obviously waste, we also used aluminium cans, which again demonstrates the reuse of waste. They're non-load bearing walls, and the cans actually just reduce the amount of cement that we use. They can also be built using adobe mortar instead of cement. But for this first Earthship in Scotland, because it was very damp at the time of building, we did use cement. The adobe mortar that I mentioned is actually a mix of earth and sand with a little bit of straw added to help bind the plaster. We used adobe extensively in the building in what they call the pack-out stage, which is basically filling the gaps between the tyres, and also for the several layers of plaster required to achieve a smooth wall which hides all the bumps of the tyres. At that stage we found swimming pool floats to be invaluable, which we couldn't unfortunately buy in Scotland, but for curved walls they're ideal. The other thing that we noted was applying adobe plaster in the winter in Scotland means it takes a long time to dry between coats, and mould or fungus can actually grow, but we simply brushed it off when the plaster was dry and applied the next layer, and we had no problems with it returning. We also tried our hand at clay plastering earlier on after the pack-out stage. We were trying to take a shortcut and applied it very thickly, and we also didn't use sand, which was a great learning experience for all of us. The result was disastrous, and it all fell off the walls. The roof on the Earthship is unusual. It combines what is known as a warm roof and a cold roof, which refers to the position of the insulation. A cold roof is the common pitched roof with the insulation low down near the ceiling. And a warm roof is the more common design in a flat roof design with the insulation above the ceiling on the outside of the building. In the Earthship, the finished layer of the roof is a synthetic rubber membrane called EPDM, which has a lifespan of about 40 years. The water is caught on the roof and it's channelled into a storage tank which is buried at the side of the building. The first filter the water goes through is pea gravel, which you can see it lines the tank lid. Once the water is in the building, it travels through what we call a WOM, which is a water organising module. And basically it's just a panel with filters and a pump on it, which allows the water to be conventionally used in the sinks and the other appliances. The WOM pumps the filtered water into a pressure tank and a hot water cylinder for use in the shower, in the kitchen and the wash hand basin. Well, after the water has been used to have your shower in or cook your dinner with, we call it grey water then, and it goes into what we call a grey waterbed. And in there it seeps through layers of gravel and sand and activated charcoal and also some sphagnum moss filters. Basically the system is a planter bed filled with both perennial and annual plants, and we've got edible and non-edible varieties in there. The aim is to have as many plants growing all year round as possible, because they are what transpires and evaporates and oxygenates the water. The grey water beds in an Earthship are a great opportunity for creating year-round food and greenery in your home. Once the plants have finished with the water, it reaches the end of the grey water bed and we pump it back to flush the toilet. This is actually the water's third use and reduces water consumption a lot, and we now call it black water. The sewage, as we call black water, is piped into another planter bed which is outside of the building. This is also made up of layers of gravel and sand and soil. The solids of the sewage are held in an infiltrator which we made from plastic drums to create, it's like a vault-shaped vessel, and it sits on a shelf above the water level. The solids are broken down slowly as the toilet gets flushed, and the plants absorb the small particles and the waste water. And again, the sewage system of an Earthship is an opportunity to grow food. We decided to cover the planter bed in Scotland, the black planter bed that is, because of the high rainfall that we have. All our power comes from renewables. The Earthship is not connected to the mains at all. And we have what we call a hybrid system. We've got solar panels on the front of the building, we've got a wind turbine, and we've also got hydropower. I think this almost guarantees that we'll never run out of power. The power is actually stored in a 24-volt battery on the roof of the Earthship and is converted inside the building by an inverter. The power is then AC and used conventionally as grid-connected systems run. Earthship Fife has been built by 230 volunteers from all over Britain and other countries. It has inspired a lot of people and has seen new projects being spawned, some of which have already come to fruition. As an organisation, we don't feel that SCI's work is done, but seeing Earthships in Scotland as affordable homes in the future is not far away. Earthships touch people because they are simple, they're logical and literally part of the earth. They offer a life that takes pressure off the planet and off the people that live in them. The people who want to live in them want to build a home for themselves that gives back to them some of the responsibility of how they actually live. Decisions on how their house works and how they use their resources are put back into their own hands. 2 years ago, when we set out to build Earthship Fife, we had no experience. Most of us didn't even have any building skills. We just got on and did it. So can you. Making mistakes is fine. There is no other way to learn. And if we look back to our original questions, what can they look like in Scotland? Will they get planning permission? Yes, definitely. And do they work in the Scottish climate? Yes, they do, very well. And what do they cost to build and live in? Well, the answer to that is a lot less than a conventional house. And do people want to live in them? That's another yes. 2 years ago I wanted to, and I still do. Do you?